We'll now talk about some of the consequences of plane separation. And before we do, a quick note on the proofs. So far, all of my proofs that I've done were relatively short and only involved direct reasoning. However, now I'm going to introduce two different properties for our proofs that I will use here. The first is the trichotomy property. It says that either A is less than B, A is equal to B, or A is greater than B for any two real numbers A and B. So if I want to actually prove that A is equal to B, I can show that this is true by assuming either A is less than B or A is greater than B and getting a contradiction as a result. The other thing I'm going to use is the contrapositive. So first, we want to show that A implies B. In order to use the contrapositive, we'll assume that B is false, that it's not true, and then we'll show that A cannot be true either. And that's another way to show that A implies B. So when I'm doing my consequences of plane separation, I will use these two things right here. Our first consequence says that if A is a point that lies on some line L, and B lies in one of the half planes H determined by L, then every interior point on the segment AB lies in H. So essentially, all of the interior points on the segment are going to be on the same side of the line. So we start by letting C be any point such that we have the betweenness relation ACB. So this means that C is on the line segment AB and is an interior point. So we know that either C is in H, C is on the line, or C is in the other half plane. If C is on our line L, then the line L is the same as the line going between points A and C. So it's the same as line AC. Since we have the betweenness relation ACB, we know that these are all on the same line, so therefore B would also be on that line. But that's a contradiction because I said B is in the half plane H. So that tells us that it cannot be on the line. Now we're going to assume it's in the other half plane. If C is in the other half plane, then our line L must intersect the segment BC at some point D. And this was given to us by our initial plane separation postulate. So we know that this must happen. If they have 2 points on opposite sides, then the segment between them has to intersect the line. And we'll say it intersects at point D. So now I know that I must have the betweenness relation ACDB. So that means it must be true that ADB. Since I know that both A and D both lie on L, that means L is equal to the line between A and D. And since B also lies on the line between A and D, that means B must also be on L, which once again is a contradiction. So therefore I have that C must lie in that half plane H. It must be on the same side of the line. And so we proved this using that trichotomy property. I had 3 things that had to be true. One of these 3 things had to be true. I showed that 2 of them couldn't be, so I'm forced to use the third case. I do have a corollary to this. So if A lies on my line, B lies in my half plane H1, and I have the betweenness relation ABC, where AC is less than alpha, then C lies in H1. So essentially, the theorem told me that every interior point on the segment must lie in the same half plane. And this says if I actually draw the ray with endpoint A and passing through the point B, that entire ray is in that same half plane. And I won't prove this. It's very similar to the proof that I did for the last theorem, so I encourage you to try to do it yourself. My next consequence says that if A lies on my line L, and B lies in one of the half planes determined by L, then every interior point of ray AB also lies in H. So here's my line L and a point A on it, and I'm going to consider H to be above this line. I also have point B that lies in one of the half planes, in particular the one above. And I'm in particular concerned about the ray AB. So here's my ray. I'm going to look at interior points, and there are 2 possible interior points for this line. C is going to be an interior point provided either ACB or ABC. If I have that it's ACB, then C is actually on the line segment between A and B, and my first theorem actually gave me that that was definitely in the same half plane H. If we have the case ABC, then C is further out than B, and that's what my corollary gave me, that that point was also in the same half plane. So we have that this one has to be true.